Okay. So uh, today we will cover the load curves and selection of generating unit. Then what are the methods of meeting the load? Then we further discuss the interconnected grid system. And in last we will see the distributed and dispersed generation. Okay. So the first topic, that is the load curves and selection of generating unit. So as you know that the load on the power station is varying in nature. It is never constant. So single generating unit will not be economical position to meet the varying load. Okay. So number and size of units are selected in a such a way that they correctly fit the station load curve. For example, if we see the figure 1, so this is the particular load profile curve, and if you see the figure 1, so minimum load demand is approximately it is around 50 kilowatt, whereas your maximum demand reaches up to the value of 500 kilowatt. So if we have the single generating unit, so it's a hardly need any mention that use of single unit to meet the varying load will be highly uneconomical. The reason being is that if we have the single generating unit, the efficiency of the machine, and if it is alternator in a case, so the maximum efficiency will be around 75% of its rated capacity. Then what we have to do? So we have to go for a number of generating units. Means in a plant we have to we have 2, 3 or more than the generating units depending upon our requirement. So for figure 1 and in figure 2 we have taken the 3 generating units, namely 1, 2 and 3. So it means the total plant capacity is divided into several generating units of different sizes to fit the entire load curve. So for that, if we see the time from 12 midnight to it's approximately 7 a.m. So only unit 1 is put in operation, and from 7 a.m. to approximately it is the 12 noon, unit 2 also is started. The reason being is that the demand is increased after 7 a.m. So unit 1 is not capable to handle this type of load, because the unit 1 can around handle 150 kilowatt load. Okay. So from 7 a.m. to 12 noon, unit 2 are also started. So it means both unit 1 and 2 are in operation. Further, if we analyze the figure after 12 noon to 2 p.m., again the demand is very less. Okay, so unit 2 is stopped here, because the only unit 1 can handle right now, because the load requirement is less than, it is 150 kilowatt. Okay. So then if we move from 2 p.m. to approximately it is the 5 p.m., suddenly load is increased. So unit 2 is again started. Now both unit 1 and 2 are in operation. If we further visualize the figure from 5 p.m. and it is approximately 10:30 p.m., the load demand is increases slightly and reaches to its peak value. So it means unit 1, 2 and 3, all units are put in operation. Okay. Then from 10:30 p.m. to 12 midnight, again the load demand is decreased. So now unit 3 can be stopped and only unit 1 and 2 are operating. So what I am trying to say here, by selecting the proper number of size of units, the generating units can be made of operate near maximum efficiency. So that will give you the overall reduction in the cost of production of electrical energy. So this is all about the selection of the important points in the selection of unit. Okay. So basically we have to make the 3-4 points in the selection of generating units. Okay. And what are those points? So please what are those points? See here. The first point, that number and sizes of unit should be so selected that they approximately fit the annual load curve of the station. The unit should be of different capacity to meet the load requirements. Okay. Then moving to the third point, the capacity of plants should be made 15% to 20% more than the maximum demand to meet the future load requirements. So in this way we have to select the generating units so that can fit the station load curve. So moving to the next point, that is, what are the methods of meeting the load? Is it my voice is audible?
Yes, sir.
Okay. So methods of meeting the load. So as we have already discussed that what is the base load and peak load. So from the figure you can see 20 megawatt is the base load of the station. because 20 megawatt is always available, whereas above the 20 megawatt we have the peak load. So now question is that what method we will adopt for meeting the load demand. So as we have seen, the total load on power station consists of two parts, base load and peak load. Okay. So in order to achieve overall economy, the best method to meet the load demand is to interconnect two different power stations. So one power station can be operated as a base load, and other power station can be operated as a peak load power station. So now we have to select which station will work on base load power and which will use to supply the peak loads. So the more efficient plant is used to supply the base load, that is known as the base load power station, and the plant which is less efficient is used to supply the peak loads, known as peak load power station. Actually, there is no hard and fast rule for selection of this base and peak load station. It is totally depend upon the particular situation. For example, we have taken here as a steam power plant and the hydro power plant. So in the figure 1 on the left side, you can see that this is your for the steam, and below 20 megawatt we have for the hydro. So in the summer season or rainy season, when water amount is available, so hydroelectric plant can be used to carry the base load, and steam plant supplies the peak load. However, when the water is not available in sufficient quantity in the winter season, the steam plant can be carried as a base load, and hydro plant carries the peak load. Okay, so depending upon the availability of power and the requirement, we can choose the base load as well as the peak load on power station. Okay. So now moving to the interconnected grid system. So basically the connection of several generating units in parallel is known as the interconnected grid system. So, what is the reason for the, or what is the advantage of interconnection of grid system? Although interconnection cost is, if we interconnect the various stations, then the cost will increase, but the benefit derived from such arrangement is gaining, and the some advantages are listed here. The first thing is that the main important exchange of peak loads. So it is the important advantage of interconnected system is that the peak load of the power station can be exchanged. Suppose that if we have interconnected two plants A and B, and the plant A is not able to handle the load, then the plant B can give it to the power to handle the such type of load demand. So if a load curve on a power station shows a peak demand that is greater than the rated capacity of plant, then excess load can be shared by the other station interconnected with it. Second point is use of older plants. So the interconnected system gives an opportunity to use the older and lesser efficient plants to carry the peak load demands of shorter duration. Although such plants may be inadequate when used alone, therefore interconnected system gives a direct key to use of older plants. So with the interconnection, we can also use the older plants. Third point, ensures economical operation. The interconnected system makes the operation of concerned power station quite economical. The reason being is that the sharing of load amongst the station is arranged in such a manner that more efficient stations work continuously throughout the year at the high load factor, and less efficient plant works for peak load hours only, thus ensuring the economical operation of power plant. The fourth point, that increased diversity factor. So the load curve of different stations are generally different. That result is that the maximum demand on the system is much reduced as compared to the sum of individual maximum demands on different stations. In other words, the diversity factor of the system is improved, thereby effective capacity of system. And last point, last advantage, reduces plant reserve capacity. Every power station having the reserve capacity for the emergency conditions. However, when the several power stations are connected in parallel, the reserve capacity of system is much reduced because the interconnected system that can handle the peak load demand of the power station. Therefore, this increases the efficiency of system. So we have seen the various advantages of interconnected grid system, and these are listed here. Okay, so if it is asked to you, that is, what is the advantage of interconnection system? So you can answer. Now, coming to the last point, that is the distributed and dispersed generation. So just wait for 1 minute. So if we talk about the distributed generation, okay, so what is the, first you should understand what is the distributed generation. Suppose that in the Leh, basically in Ladakh, so if we have the power requirement in Leh, it's, let's say it's a 500 kilowatt. So what we have to do? So Leh is basically nearer to the Delhi or Punjab. So we have to interconnect the transmission line. We have to erect the transmission line in order to supply the power at a Leh. So during interconnection of the transmission line, we have to invest the very huge cost because the distance is too much. So what we can do? There are two options. The first is that we have to erect the transmission line from the nearer places to the Leh, and then we supply the electricity power to its locality. And second one, we can generate power at Leh places itself, because during the erection of the transmission line from Delhi or Punjab, we have to invest a very huge amount. So in order to save that amount, why not we are going for generation of the power in the Leh itself. So that gives the concept of distributed generation. Now I am going to give you the exact definition of distributed generation. The deregulation of electricity supply worldwide brings new perspective for a small generation known as distributed generation. So basically, distributed generations are mainly the small generations from kilowatt to some megawatt, and that can be installed at a various strategic point throughout the area, so that each provides power to the small number of consumer nearby. These may be solar, mini micro hydro, or wind turbine units, highly efficient gas turbines, small combined cycles plants. These are the most economical choices. So DC are basically the small generations of kilowatt to the megawatt. Okay, so depending upon the requirement, you can also go for the distributed generation. So now coming to the dispersed generation. Dispersed generation refers to the use of still smaller generating units, and these are the less than the 500 kilowatt output, and that can be installed in the severe individual homes or businesses. For example, micro gas turbine, fuel cell, diesel engine generator, a small wind, and solar system make up this category. The dispersed generation has been used for decades as an emergency backup power sources. Most of these units are used in domestic sector as an emergency supply during the blackout periods. So distributed or the DC generators can be used standalone or autonomous or grid connected depending upon the requirement. Okay, so this is all about the distributed and the dispersed generation. Okay, so let me stop the recording.